Number 71. The decomposition of hydrogen peroxide, which is H2O2, has been used to provide thrust in the control jets of various space vehicles. Pretty cool. Using the data in Appendix G, determine how much heat is produced by the decomposition of exactly 1 mole of H2O2 under standard conditions. And then they gave us the formula here, which I already copied for you guys. So we have 2 H2O2 liquid yields 2 H2O gas plus O2 gas, right? And now, what I did also was I went into Appendix G and I wrote down the delta H values that correspond with each component here. I knew that we were doing delta H because they asked for how much heat is produced. Heat energy is delta H, it's enthalpy, okay? So I also just want to say, be careful. Some of these, like when I was looking in Appendix G, there is H2O gas values, and then there's H2O liquid values, which is a completely different number than this. So just make sure that you match up the states. This is like one of the only times, or a couple of times, in which states actually matter. All right? So I wrote down the balanced equation, and I see that it's balanced because they already gave me coefficients. So the first thing I have to do is I have to basically get the heat that's produced for this reaction. Well, how do we do that? It's a simple formula. It's this guy right here. The delta H of a reaction, RXN, is just equal to the sum, this little symbol means sum, of all the delta H's of the products minus the sum of all of the delta H's of the reactants, aka addition. So what we're going to do is we have to get one number for the reactant side, one number for the product side, and then we just plug it into here. Okay, so in order to do that, we take the numbers that we found in that appendix and we multiply by how many we have in our balanced equation. So for example, there was 2 H2O2s, so I'm just going to times by 2, the negative 167.78. There were 2 H2O gases, so I'm going to multiply that number by 2. And then there was no number in front of the O2, which means that it was a 1. So I just multiply by 1. Now, I have to add them together. You see how it was H2O gas plus O2? So I just have to add these two numbers together. This was the only compound on the reactant side, so I don't have to add it, but I do have to multiply by 2. So let's get the total numbers. Let's see, 2 times negative 187.78. I get negative 375.56 for my total reactant side. And then for my product side, I'll just take 2 times negative 241.82. So I get a negative 483.64. Okay, now I'm ready to find out what is the delta H for this reaction. Well, it's products minus reactants. The product was the negative 483.64 minus the reactant, which was a negative 375.56. And remember, keep change. Minusing by a negative, right? You just plus a positive. So let's just see what this delta H would be. Okay, so we got negative 483.64 plus 375.56. So I get an overall delta H of negative 108.08, and that's kilojoule per mole. All right. Now, this is not the answer that they wanted. I'll tell you in a little bit, but we needed to do this to figure out how many moles they wanted to do this for. So what I'm going to do is I'm actually going to now shift this over to the left-hand side because I want to do the math over on this side right here. Okay, so we wanted to know how much heat is produced by exactly 1 mole of H2O2. Now, if we take this number, right, and this is like a conversion factor. I have 2 units. I have a kilojoule and I have a mole. So I can say that for every 108.08 kilojoules that is being released, the negative means released, this will equal to how many moles? Well, this really depends on two things, the compound that you're talking about and what the number is in the front. So for example, if they're asking for H2O2, I'm going to say that it's going to be equal to moles of H2O2. But now how many moles of H2O2 does this number correspond to? You gotta look in the balanced equation. Always the number that they give you is going to be the coefficient here. So 2 moles of H2O2 will produce negative 108.08 kilojoules, or you will release 108.08 kilojoules. For example, if I wanted to say that the 108.08 kilojoules were going to be released, and I was focusing on moles of O2, how many moles of O2 would I say? Now I would only say 1, because there's a 1 in front of here. So that's the pretty tricky part of doing these conversions. So I'm going to use this conversion to solve for what they wanted. They wanted only 1 mole of H2O2. So if I only want to find out how many moles or how much heat is going to be produced by only 1 mole of H2O2, what did I do from 2 to 1? Either multiplying or dividing, right? I could basically go from 2, I divided by 2 to get to 1. So whatever I do on one side, I just have to do on the other side, right? So I will divide by 2. And that would be the answer, basically. So it's negative 54.04 kilojoules would equate to 1 mole of H2O2. So basically, if I wanted to sum this up as a ratio, what we would just say is we would say that for every 54.04 kilojoules that is being released, the negative means released, this would be equal to 1 mole of H2O2, or we could just say that this is per mole of H2O2, right? Because per mole means that it's per 1 mole. So that would be your final answer. Okay, guys, look at that. What do you think? Hopefully this helped. Let me know in the comments. Subscribe to the channel. Thank you so much for that. I really do appreciate it. Just gets the word out there that this service exists in the world of YouTube. So I think it's pretty cool. Thank you so much, and I will see you in future lessons. Be well, all right? And good luck on all your future tests and quizzes. See you later. Bye-bye.